It is the only metal in the world that is liquid at room temperature. Once able to call the wind and summon the rain, people compared it to the cure for syphilis. And even historical figures like Qin Shi Huang and Lincoln were deeply affected by it. Mercury is the first superconductor discovered in human history, and it has a scientific name, mercury. Once you put the two together, a wonderful reaction known as the Lu-Gongqi reaction occurs. Today, we will thoroughly uncover the long-hidden secrets of mercury. Like gold, silver, copper, iron, and aluminum, mercury also comes from ores deep in the mountains, and these ores are characterized by their deep, vibrant red color. Moreover, the supply is very high. Basically, around 80% of them often appear in ancient China. For example, cinnabar is the product of grinding it into powder and extracting it, which can be used as a pigment or for carving seals. However, as people understand more about mercury, this element is gradually being replaced by the market. For example, can you imagine pushing the factory out with a human cart? The few small tricycles are also used to transport generators. In fact, this mine is the world's largest arch ladder ore deposit in Kyrgyzstan. It once produced a record amount of ore in the Soviet era. Now there are only a few old men left to operate it with enthusiasm. If converted into RMB, each person only earns 1,130.5 yuan per month. Let's prepare for the heating and separation process. First, we need to decompose the mercury sulfide in the ore at a high temperature of 500 degrees Celsius into mercury vapor and sulfur vapor. The resulting mercury vapor will condense on the walls of the pipes, which serve as a medium for transport, and then it will be converted into liquid mercury by a condenser. At this point, we need to fill it into flasks. According to international standards, each flask can hold up to 34.5 kilograms. But don't be fooled by its small size. It looks like a fire extinguisher. Yet even an average adult man needs to exert quite a bit of effort to move it. Can you imagine that such a small flask weighs about 70 pounds? The elderly men in Kyrgyzstan might not be as resistant to mercury as we might think. You can actually put your hand directly into the mercury and stir it, or even let it flow freely in the palm of your hand. This obviously goes beyond the scope of the old generation's teaching that we should take good care of the thermometer. Mercury is the only metal that can be liquid in a greenhouse. Its biggest feature is its high density. You can even put a weight of about 2 kilograms on it, and it will float like a boat. Because mercury's density exceeds that of cast iron by more than 14 times, its properties have led to an unprecedented fascination with it in ancient times. Just look at the elderly man in front of us. After shaking it, he even took a sip. In fact, every absurd treatment stems from humanity's hope to survive. The History of Absurd Medicine is a Western book that describes bizarre medical techniques. It introduces the use of liver mercury to treat syphilis, constipation, influenza, depression, and parasites. Back in those days, any problem you could think of would get you a tube of mercury. Now let's reveal the principle of the Lu-Gongqi reaction. If we place a few drops of mercury in a groove on an aluminum plate and let it sit for 5 minutes, there will be no visible changes on the surface, but this is due to a layer of protective oxide film that forms on the aluminum plate. The barrier thus serves as an isolating function. We also tried using a small electric drill to penetrate the oxide film, but this didn't allow the mercury to form a dome. We then removed the mercury from the groove, preparing to treat it with hydrochloric acid. Next, hydrochloric acid is a substance in the form of a strong acid, and this reaction can convert the oxide layer in the oxide film into chlorides. During this process, the density of the groove changes in a way that is not visible to the naked eye. Then wipe the hydrochloric acid clean and quickly drip a few drops of water into the groove to prevent the surface from oxidizing too quickly. Once the silver is filled, it won't take long for the aluminum-mercury reaction to occur at the contact point between the two. We can also call it a mercury alloy. This alloy has a low melting point and high fluidity. Some of the mercury flag will dissolve at the top of the mercury and then merge with the air to form white aluminum oxide, which will grow outward in an expanding manner. During the reaction, mercury will continuously destroy aluminum. Although it looks like less than a minute, when fast-forwarded, in the real world, this masterpiece took 4 hours to complete. The picture looks particularly powerful. But if you poke it gently with your hand, you will find that the strength is not very high. It is not so much an alloy. It's more accurate to say it's like aluminum tissue fibers, my day. Because after weighing, the alloy only amounts to a simple 200 milligrams. Now let's clean up the excess impurities around it. You will find that the contact surface has turned back to its original grey color. Obviously, this is because some of the mercury has dissolved into the aluminum. Next, we'll remove the excess mercury from the groove and see if we can continue to produce the aluminum-mercury phenomenon. Clearly, the mercury in the aluminum is still having an effect. This is the result captured over 2 hours, but it's not as intense as the first aluminum-mercury reaction. Picking up the brush to clean the surface, we can see that the contact area has turned back to its original silvery color. This indicates that the reaction has only completed after 2 rounds. Do you know what happens when we add water? First, we'll drop hydrochloric acid in, while simultaneously adding mercury and some clean water. This time, it won't react directly with the air anymore. Instead, it will mix with water to produce aluminum hydroxide and hydrogen gas. If you look closely, you can even see bubbles forming at the edges. This indicates that the aluminum-mercury phenomenon is still present. It was just hidden beneath the grey oxide. And then, we used tools to clean the surface of the aluminum plate. Unfortunately, the cleaning process still left some watermarks, but we shouldn't let that go to waste. Let's continue to produce the mercury gas reaction. This time, it seems to be even more thorough compared to the previous 2 attempts. If I had to describe it in one word, it would be mophead, because nothing else resembles it more. Although the mercury-aluminum reaction caused substantial damage to the aluminum structure, the amount produced during this time was almost negligible. The groove in the middle was pre-dug, and as for the surface of the aluminum plate, there wasn't even a millimeter of damage. It only left behind a layer of uneven, rough texture. It's important to know that mercury is a liquid metal. But can we turn it into a solid metal like copper? Let's take a look at the next experiment. First, we pour some liquid nitrogen into a petri dish, and then quickly pour the mercury into the liquid nitrogen. The temperature of the liquid nitrogen is minus 196 degrees Celsius, which can instantly freeze the mercury. And it allows the mercury to take on solid chunks. And even after returning to room temperature, the surface of the mercury chunks is still changing. By striking it, we can confirm that it has completely frozen. Next, let's place it in room temperature water and see what new discoveries we can make. This scene is something many people have probably never seen before. The mercury is returning, the liquid is continuously merging into the water, and eventually, it even disappears in a mist. So, have you ever had a close encounter with mercury?